Mr. Beck does your homework. This is homework number 3, question number 8, a tricky one. A tennis ball with a velocity of 10.2 meters per second to the right is thrown perpendicularly at a wall. After striking the wall, the ball rebounds in the opposite direction with a velocity of negative 8.07 meters per second to the left. If the ball is in contact with the wall for 0.011 seconds, what is the average acceleration of the ball while it is in contact with the wall? So what we have is a tennis ball that is heading to the right at 10.2 meters per second. And then it hits a wall and bounces back to the left at 8.07, they say negative 8.07 meters per second. Now, what's tricky here is that this is where velocity and speed are finally coming into play. So here, since these are vectors and this one's pointing to the right and this one's pointing to the left, what this tells you is that to the right is positive and to the left is negative. So we need to take these directions into account as we do this. So here, my initial velocity, my v0, is going to be positive 10.2 meters per second. You don't actually have to write the positive, but I'm writing it here just to make a point. My final velocity, it bounces in the opposite direction with a velocity of negative 8.07 meters per second to the left. So my final velocity is negative 8.07 meters per second. Now, in this case, positive means to the right, negative means to the left. So we can take this as positive is to the right, negative is to the left. And that's a typical convention, a typical way that physics likes to do things is right is positive, left is negative. If the ball is in contact with the wall for 0.011 seconds, that's my time, is 0.011 seconds. What is the average acceleration of the ball while it is in contact with the wall? So I'm looking for my average acceleration now. So I'm just going to write A equals question mark. The relationship I have between acceleration, initial velocity, final velocity, and time is given by A, acceleration, equals my change in velocity divided by time, is going to equal my final velocity minus my initial velocity divided by time. Now, if I plug in my values, being very careful about positives and negatives, my final velocity is negative 8.07 meters per second. So this is going to be negative 8.07 meters per second minus my initial velocity, minus that positive velocity of 10.2. So it's minus 10.2 meters per second. Notice this is negative 8 minus 10 is going to give me about, negative 18.27, something like that. But it's going to be even more negative. It's a big negative number. Divided by my time, which is a tiny little number, 0.011 seconds. So this is a tiny little number. This is going to be a pretty big number. That's going to be a pretty significant negative number. So my acceleration is going to be negative. My acceleration is going to be negative, some pretty significant number. And this is meters per second divided by seconds. So that's going to give me meters per second squared. So make sure you do negative 8.07, or whatever your numbers are, minus 10.2, whatever your number is. And so this is going to be a bigger negative number than either of those, divided by this tiny number is going to give me something pretty significant for meters per second squared. So my acceleration is going to equal some rather large number of meters per second squared.